Here's our first type of function in really discrete structures in math here, and that's injective. It's called a one-on or one-to-one function. It's one-to-one because each value in the range, and by the way, I'm going to zoom in on these here in a moment. Each one in the range corresponds to exactly one item in the codomain, just one. And you're going to see some fancy formulas that are being highlighted right now. Both are basically saying the same thing, is that, I'll do the first one, for A and for all B, x does not equal y. That implies that f of x does not equal y. So they're individual, they're distinct. That's really the same thing when we're using the contrapositive of this, is that it says, hey, if they are equal, that's because x and y are equal. So again, it's a similar one, just happened to name it one time x and the other time y, but it's still the same thread between the two. So again, there's no duplications when it comes to the overall threading that we've got. So in the example, you'll see, which I've already kind of, you see that really focusing basically from our codomain out to the domain, it's just one per each codomain. Now, by the way, you might have some of the codomain that aren't still used. So just a heads up on that. It's just what the values that are being used, they only have one response to them using f of x. This would be the bad one-to-one. Let's put it that way. For some reason, our solution for y of c happens to map to two different domain items, then that is not a one-to-one. So just wanted to show you both ends of what you could see and, well, frankly, see good and see bad.